Watch how coal does it. We burn coal to make steam. Then that steam spins a turbine connected to a generator. First, coal arrives by rail, gets stored in large piles, and moves onto conveyors toward the plant. Sorting and safety checks happen before it reaches the crusher. Inside the coal handling system, crushers grind it into fine particles. Airflow carries that powder into the boiler burners in measured amounts. In the boiler, burners ignite the pulverized coal, heating water-filled tubes. Superheaters and steam drums keep the steam hot and pressurized. The furnace transfers that heat to create steam. High-pressure steam heads to the turbine inlet. Steam rushes through turbine blades, making the shaft spin. The generator converts that rotation into electricity for the grid. After expansion, steam enters a condenser where cooling water removes heat. The condensed water returns as feed water to the boiler. Cooling towers release water vapor to the air. This continuous cooling keeps the turbine working efficiently. Boiler flue gas passes through pollution control equipment. Electrostatic precipitators and scrubbers capture soot and sulfur compounds. Captured ash and sludge are collected for disposal or reuse. Cleaned exhaust rises from stacks while solids stay in the systems. For petroleum, oil-fired plants burn fuel oil or residual petroleum to generate heat. The steam and turbine route is similar, but the fuel handling is different. Fuel oil is pumped from storage tanks and often warmed for smooth flow. Filters and valves keep impurities away from the burners. Burners atomize the oil into tiny droplets, then ignite the spray in the furnace. Heat transfers through boiler tubes the way coal-fired boilers do. Steam forms in the boiler, then is superheated to required pressure. The high-pressure steam enters the turbine and expands. The spinning turbine drives the generator for electricity output. Switchgear sends the power to substations. In the condenser, cooling water turns exhaust steam back into water. That water circulates again through the cycle. Oil combustion still produces nitrogen oxides and sulfur compounds. Flue gas cleaning systems reduce these before the gas is released. Coal plants manage bulky solid fuel and heavy ash handling. Petroleum plants may have less ash, but sulfur control can be crucial. Coal delivery relies on rail and conveyor stockyards. Oil delivery uses tank farms, pumps, and burner flow control. Efficiency depends on economizers, superheaters, and feed water regulation. Sensors balance combustion air, steam conditions, and emissions performance. Both fuels follow the same chain. Heat becomes motion, motion becomes electricity. Fuel choice mainly changes logistics and the emissions profile. When you track the loop, burn, boil, spin, condense, you can follow any thermal plant. With good controls, plants can run steadily and safely. In practice, coal and petroleum differ in cost, supply,